So this is a muscle contraction, and right up here we have the neuromuscular junction, and this is the sarcoplasmic reticulum. So the neuron action potential arrives at the end of the neuron, and the acetylcholine is released and will then bind to receptors on motor ends of the platelets of the muscle fiber. The sodium ions rush into the muscle fiber, and it will go into the neuromuscular junction. The action potential of the muscle goes into this, and the sarcoplasmic reticulum releases the calcium, which travels through the muscle fiber. The calcium binds to troponin, which is down here, and that causes the tryptophan to shift and expose the myosin binding site. Binds to the troponin, it causes this to be exposed inside the muscle. The myosin begins to bind with the actin through this, and the actin's up here. The myosin will turn, pulling on the actin filaments right here, combining with magnesium and ATP. Now, when the myosin attaches together to contract. Now, the myosin will release when the muscle is relaxed. So instead of the myosin attaching to the actin when it's contracted, when it's relaxed, the myosin will detach itself from the actin, and the myosin returns to its extended position when it is ready to be contracted. For rigor mortis, the cross bridge that is between the myosin and the actin is delayed, and ATP and magnesium are at a shortage during the first 6 to 12 hours after death, and in the muscle they have to be recreated so that the muscle can have ATP storage, because the ATP is less after death, and too much of the delayed or rephosphorylated ATP is present in the bridges of the actomyosin cross bridge, and if too much is present in the bridges, then the ATP is limited, and that makes the muscle stiff. There's also a decrease of pH during the postmortem of the muscle, and that increases stiffness. Once the muscle is in rigor mortis, that is when it enters into the resolution phase.